Basically, every year before SC and ISC, we put out a newsletter that talks about best practices in high performance computing. And so it's always based on a different theme that is voted on by the HPC community around the world. Okay, so just to kick off, welcome to the Green HPC Best Practices newsletter. I'm Aditi. I'm from the Pawsey Supercomputing Center, and I have Pekka with me.
Hello, my name is Pekka Manninen. I'm director at CSC, which is the Finnish Supercomputing Center, National Supercomputing Center, and I'm in charge of the Lumi supercomputer facility.
Awesome. Welcome, Pekka. So today, as I mentioned, we're going to talk about Green HPC and how CSC and Lumi is working to build a Green HPC center. So far, what is your experience in Green HPC as well as CSC's experience in Green HPC?
Environmental sustainability has been important for us for quite some time. And in fact, CSC has operated its supercomputers for the last 15 years using 100% hydroelectric energy, yielding low carbon footprints. And also in the recent course of years, especially when it comes to the Lumi supercomputer, we've been exploring further topics like the heat reuse or the excess heat reuse.
Nice. Cool. So with Lumi, how are you working to build a Green HPC center?
With Lumi, we have a couple of, we try to do this kind of end-to-end sustainability. So we have system level considerations and facility level considerations, of which the facility level ones are by far the most dominant when it comes to the total footprint of the system in its lifetime. So we, on the facility level, we pay attention to the electricity. Again, it's a hydroelectric energy. We are able to do it with a very low power usage efficiency. Like I said, we are exploring the excess heat or waste heat reuse to heat up the surrounding city of Kajaani, which gives a further reduction of carbon dioxide emissions in a kind of like a holistic manner of speaking, and also the construction work. So the solution how and where the data center has been built is a major considerations, as we all know, building new buildings is a very carbon dioxide intensive. On the system level, we have strive for a very energy efficient solutions. So performance per watt solution was a major consideration for selecting the node architecture for the system, and it's as also Pawsey have ended up in the same technology. So that's going to be the leading technology for quite many green environmentalists when they eventually get there. Also, we took the whole supply chain footprint in the consideration on our request for proposal or tendering process. So therefore, we kind of try to have also the system level covered together with the facility.
Nice. So in this assessment with creating this new data center, do you have any successes or learnings or advice that you have for other centers?
Yeah, let me summarize into a couple of points here. So well, first we kind of like have learned now or proved now that the supercomputers do not need to locate on the same campus as the supercomputing center or the university owning the supercomputing center and so on. But in the time of like a very strong networks, we can place the supercomputers where they are most economically and ecologically sensible. The second point on the brownfield part is that repurposing existing buildings instead of building new shiny buildings, data center buildings, are very cost and eco-efficient ways of doing it. And for making this kind of like a PR photos, we can also have like a shiny building, but which is like it's like a much less like a lightweight as it's just a frame inside a existing building. So not the whole building need to be this kind of a sci-fi block somewhere.
That's very cool. I like what you said about considering the ecology. So like how did the environment build into how was the environment a factor in creating this new center?
So like I said, so it's an existing former paper mill. So it was like just an empty building with the manufacturing, paper manufacturing went somewhere in Latin America. So there was just like the hall was remaining. So we basically could have put the supercomputer on the concrete slab floor, but we ended up doing this kind of a more like a some kind of a shell around it, and it didn't like cost much to put a little bit of decorative plating on top of that. So it's most of the construction, or let's say 90% of the construction was already in place.
Already done.
For our data centers. So.
Nice. I was speaking to a colleague at NERSC earlier today who said that because of their location in the Bay Area and being back in Berkeley, they were able to take advantage of the airflow and the low temperatures to cool their systems. So I think that it's just like natural air cooling their systems. I would imagine where you are, it's pretty nice and cold, or it can be. So are there things like that those kind of environmental factors that help with the cooling systems that you have as well?
Yes, certainly we can do pre-cooling throughout the year. So every single day of the year we can just basically open up windows in a way. So we can take the heat to the roof and like let it out. But like I said, so the excess heat reuse has been one of those lessons learned for us. So the utilization of the excess heat is in a great way of reducing both like a net costs and the net CO2 emissions. So in our case, it was pretty easy because it's heat, and we basically use it for the district heating system. So that's like a less of a technology being needed, basically just heat pumps. So it's a good case for us. So we don't let the heat out at all, but use it for heating the city first, and then it's basically released. But there are other technologies for the excess heat, the waste heat reuse being proved, or the different proof of concepts have been demonstrated. Also, also regions that are not in a cool climate. So there are many concepts that can be applied everywhere on the globe.
That's fantastic. That's really cool. So from a user perspective then, why do you think that it's important for users to be engaging with a supercomputing center that is prioritizing the environment and efficiencies in their energy consumption?
I would put this way that it's the ecological sustainability of an HPC installation, or the ecological sustainability should be the sender's consideration and not the end users. So instead of providing power metrics, so your job consumed this and this many joules of energy, is not something that we really drive Green HPC or should be driving Green HPC, but it's something that we as a service provider should do it in a sustainable manner, and then the users just focus on doing their science. Nice. So I of course hope that the users do appreciate it, but from users' point of view, they don't see a difference whether we would be running in a kind of like a business as usual, or we do our solution. So it shouldn't be reflected. It is not, and it shouldn't be reflected to the end user experience of the installation.
Absolutely. I really like that it for a place that consumes so much energy, the onus is definitely on you to ensure that you're being as efficient as possible. And on that, and speaking of users, the efficiency of their code can depend on how much energy that they're using and the processing power that they're taking up with their work. So do you offer support in terms of training indirectly, helping the efficiencies of your systems by training your users and educating them on how to be more efficient and optimize their code when they're using your systems?
In this spirit, it is our headache. So we at least don't have any grand plans for that one. So I think what user can do is to just like try to be as efficient in terms of performance. So optimize the codes for application performance, and that's it. And then we basically build the sustainability on the facility level.
That's fantastic. Cool. So it sounds like you're doing some really cool things you've taken into consideration, like recycling a building basically, which is fantastic, really reducing those costs and the footprint that you have when creating an entirely new center. You're working with your researchers, you're using the environment around you to cool your systems. That's really fantastic. Cool. Yeah, I don't know if you have any more to add or.
Yeah, perhaps stressing that basically the foundation consideration is the used energy. So basically everything beyond that is just like a ripples if one resorts into oil or coal-based electricity. So basically it needs to start from the factor of using a wind or solar or hydro or nuclear power for the facility. So.
Yeah, and so your case is how does the hydroelectricity system work that you're using?
It is bought from the main grid. So we just like a board certified power. So Finland is very abundant on green power. In it. Also, the region has lots of hydro power plants, also solar and wind there. So basically, the whole northern Finland is using only on like a
that is so cool.
Like a renewable carbon neutral energy. And then we just like bought it from the electric grid as a certified solution. So
yeah, that is so cool. That's fantastic. Yeah, that it's powering half a country. That's just fantastic.
Yeah, like I said, so it's just the supercomputers should be hosted in a location that allow that. So and then they don't need to be on the university campuses or next to the where the stuff is. So the computer itself can be elsewhere.
Wow, cool. Okay, that's really interesting. And I hope that people take that away with them when they watch this, because I think that's a really important point to make, that consideration of not just having a site, but deciding where this site should be so that you can build the best kind of center in a place that is taking advantage of renewable energy or really minimizing that consumption. That's so cool. I really like hearing that. Yeah. Cool. Okay. Well, thank you so much for joining me. I think we've covered a few really interesting points, and
thank you. It was a nice chat.